Hi guys, welcome back to our mathematics tutorial. Once more, my name is Peter C. Dogba Jr., your math tutor and an instructor of mathematics at the University of Liberia. In this lesson, we want to look at additional problems under reducible to variable separable methods. And we said if you have a differential equation of the form dy by dx is equal to f of ax plus by plus c, you can substitute what is within here with some other unknown variables and be able to reduce that differential equation into an equation that can, that you can apply variable separable method on. So let's look at an additional problem. We've been solving few problems under this topic. So let's look at this question. Says dy by dx is equal to cos of x plus y. If you can remember, we solved a problem like this, and we solve a problem like dy by dx is equal to sine of x plus y plus cos of x plus y. So this is also similar. So I could also give you, okay, we'll do another problem in the next video. But let's look at this one quickly. Now, dy by dx is equal to cos of x plus y. If we only had a single variable within this parenthesis, it would have been easier for us to separate the variables and find the general solution of this differential equation. But because you have two separate variables, it's a kind of challenging thing for us to separate the variables. So what we need to do is to substitute this x plus y with some variable. So we say let u equals to x plus y. And like you saw from previous videos, we can easily differentiate both sides, considering that u and y are functions and x is the variable of the two functions. So we differentiate this. We have the u with respect to the variable of the function within u called x. This is also 1 plus, this is also 1, but we attach the y by dx. The next target is to solve for dy by dx because we have dy by dx here. So the u over dx minus 1 is equals to dy by dx. So we're done solving for dy by dx. Next, we go back to the problem now and replace dy by dx is du over dx minus 1 equals to cos of u, because this is this is u. Now we can separate the variables and find the general solution. So we have du over dx is equals to 1 plus cos of u, right? Because if this one goes across, it becomes positive 1. So we cross multiply. We have du all over, let's say du now is equals to 1 plus cos of u times dx. We don't need 1 plus cos of u because we only need what is, we only need the expressions with x on this side of the equation. So we can divide 1 plus cos of u and 1 plus cos of u. So what else? Get rid of this. We have du now all over 1 plus cos of u is equals to dx. Integrate both sides. Now, we saw in previous video that we use the identity, the half angle identity for this expression. So we know that cos of u over 2 is equals to plus or minus the root of 1 plus cos of u all over 2. So if we square both sides, it means we will have cos square u over 2 is equals to 1 plus cos of u all over 2, right? So if we multiply this 2 by this, we will have 2 cos square u over 2 is equals to 1 plus cos of u. So wherever we see cos 1 plus cos of u, we're going to replace it with 2 cos square u over 2. So this now gives us 2 cos square u over 2 equals to x, the integral of the x. So this 2 comes outside, 1 over 2. And then what is left here, 1 over cos is just equals to secant, the secant square u over 2. The u is equals to x. So 1 over 2, the integral of secant is just tangent square u over 2. But if we were to say let t equals to u over 2, the t will be 1 over 2 du, right? So this 1 over 2, when we integrate this secant square u over 2, we must attach 1 over 2. It is part of it, right? Because let's assume we were to go bit by bit, right? We say, okay, let t equals u over 2. Because we don't want a kind of angle here that has a denominator greater than 1. So if we differentiate, we have the t is equals, the derivative of u is just 1. So it's just 1 over 2 du. So 1 over 2, the integral of secant square u over 2. What is u over 2 now is t, right? And then the du now is 1 over, okay, so the du now will just be 2 dt, right? Because we multiply this 2 by this, dt will give us 2 dt, all equals to x. So this 2 comes outside, we cancel this other 2. So we have the integral of secant square t dt, all equals to x. What is this? This is just tangent of t equals to x plus some arbitrary constant c. So what is t? T is u over 2 is equals to x plus c. And then what is our u? So we have tangent u now is x plus y. So it's x plus y all over 2 equals x plus c. Good. So this is now our final answer for this problem. So let's solve another problem. Solve another problem. So dy by dx is equal to 1 all over x minus y plus 1. So let's look at this problem as well. In similar form and minor, we replace this x minus y with some other variable, right? So we say let u equals to x minus y. And then the u now by dx will just be 1 minus dy by dx. Next step, let's solve for dy by dx. So we have dy by dx coming on this side of the equation will be dy by dx, or equals to 1 minus du by dx. So we go back to the problem to replace. Where's where we see dy by dx? We put 1 minus du by dx, or equals 1 over, this whole thing now is just u plus 1. So we try to separate the variables. So if this goes across, this 1 and this 1 cancel, right? So this now becomes negative du or over dx is equals to 1 over u. So we cross multiply. Negative du is equals to, so this is u, du is equals to dx. Integrate both sides. So this will just give us negative u squared over 2 or equals to x plus some arbitrary constant c. So what is there? What is u? U is x minus y. So it's x minus y all squared over 2 is equals to x plus some arbitrary constant c. So thanks all so much for watching and see you in our next lecture. Thank you. Please subscribe to our channel.